Now we're doing section 9.3 and we're finding orthogonal trajectories, and I have a three-step process. And the first step is isolate the unknown constant k, mc, whatever, and what we're given is k x squared plus y squared equals 1, so we're going to have to isolate this k. Once that's done, we're going to find dy dx, or y prime, relative to that equation. And then we're going to build the dy dx for the orthogonal trajectory. In other words, we're going to take whatever we came up with in 2 and replace it and replace it with its negative reciprocal. And then do what needs to be done in order to construct the orthogonal trajectory, or as I said, solve for the orthogonal trajectory. So first step, isolate k. Well, k equals, and first of all we're going to subtract y squared. And then once we get that done, we're going to have to divide by x squared. So there's k. Now we'll take the derivative of both sides, and the derivative of constant is 0. And we have to use the quotient rules, so we'll square this denominator and get x to the 4th. Then we'll hold x squared constant and take the derivative of 1 minus y squared, which is negative 2y, y prime. And we still have this factor of x squared here. And now, we're taking the derivative with respect to x. Now we'll hold 1 minus y squared constant and take the derivative of x squared, which is 2x, and that's times 1 minus y squared. Okay, now setting this equal to 0, all we need to do is set the numerator equal to 0, and then we'll add 2x times 1 minus y squared to both sides. So ultimately we have this minus 2y, y prime x squared equals 2x times 1 minus y squared. Now we need to isolate y, so we'll divide, or we have to isolate y prime, I beg your pardon. So we'll divide both sides by negative 2yx squared. So y prime equals negative, that took care of the negative, 2x times 1 minus y squared divided by 2yx squared. Now the 2's divide out, and one of the factors of x divides out, and we get minus 1 minus y squared over xy. And so we just determined what y prime is. Then for the orthogonal trajectory, we need the negative reciprocal of this. So we'll say dy dx, and this is for the OT, for the orthogonal trajectory. That's going to equal negative times a negative is positive, and we exchange numerators and denominator, and we get 1 minus y squared. Now, we'll multiply both sides by 1 minus y squared and divide both sides by y, and we wind up with 1 minus y squared over y dy, and I'll multiply both sides by dx also, and we get an x dx. Separable differential equation. So now this becomes 1 over y minus y squared over y just becomes y dy equals x dx. Now we'll integrate both, and we get ln of y, absolute value, minus y squared over 2 equals x squared over 2 plus c. And we've got it. This is the orthogonal trajectory relative to the equation we were given. And we're done.